In this lesson, we're going to examine applications of systems of equations. At the end of the lesson, you should be able to answer, how can a system of equations be used to model a real-life situation? And then, once you've modeled it, how do I choose which method is best to solve a system? So in the first scenario, it says, a rental car agency charges $15 plus 11 cents per mile to rent a car. Another agency charges $18 plus 8 cents per mile to rent the same car model. So we're being asked to write a system, but first of all I want to point out how I recognize that a system is applicable. What I notice is there are two different agencies being described, and the cost as well as the number of miles. So I recognize two variables, and then two separate agencies show me that I'm going to be able to write two different equations. So I'm going to allow M to be the number of miles. I'm going to say C is the cost of renting the car. So I'm going to describe the first agency. I'm going to say that the first one would be C equals $15 plus 11 cents would be 0.11 per mile. Whereas the second agency would be C equals $18 plus 8 cents per mile. So here's my system. Now, I'm going to solve this system to determine how many miles will have to be driven so that the cost would be equal regardless of which agency you rent from. So what I notice is these are both in slope-intercept form, even though I'm not using y and x. Because of this, I think that substitution would be the easiest method. So what I'm going to do is I'm going to take this expression and plug it into C, into the second expression, which will give me an equation which is 15 plus 0.11 m is equal to 18 plus 0.08 m. So now I'm going to solve this equation. I'm going to get my variables on one side by subtracting 0.08 m from each side, which gives me 15 plus 3 cents m equals 18. So I subtract 15 from each side and I get 0.03 m equals 3. Then I divide each side by 0.03 to get the answer of m equals 100. I also need C. So I need to plug this in for my second step into either equation, and I'm selecting to plug it into the first one. So 15 plus 0.11 times 100 would be 15 plus 11, which would be $26. So this tells me the ordered pair 100 miles will cost $26. So I said if I drive the car 100 miles, both agencies will cost $26. Let's take a look at the second example. In 1 week, a music store sold 9 guitars for a total of $3,611. Electric guitars sold for $479 each, and acoustic guitars sold for $339 each. How many of each type of guitar were sold? So I'm going to let E be the number of electric guitars and A be the number of acoustic guitars. I could use X and Y, but it's easier on my brain if I use the letters associated with the words in the problem. So, the first thing I notice is there are a total of 9 guitars sold. So I'm going to say E plus A is equal to 9, because that's talking about the quantity. So this equation is all about the quantity sold. And my second equation is going to be about the cost, or the money. So 9 guitars were sold. And then we know that an electric guitar was $479. So 479E plus 339 times the number of acoustic for a grand total of $3,611. Here is my system of two equations in two variables. So now what I'm going to do is solve this. I'm choosing to use elimination to solve this system. So I'm going to choose to multiply the top equation by negative 479. That will create a pair of opposite coefficients on the e's, and they will be eliminated. So my first equation will become negative 479e minus 479a equals negative 4,311. Now I'm going to stack my equations, and then I'm going to add them together. So I'm just recopying the second equation beneath it. Now I'm going to stack and add. My first set of variables are eliminated. It would be 0. So I get negative 140a equals negative 700. So I'm going to divide each side by negative 140 to find the value of a, which gives me a equals 5. Now I just plug back in, and I'm going to plug back into the first equation. It would be e plus 5 equals 9. So subtract 5 from both sides, and I get e equals 4, which tells me that 5 acoustic guitars and 4 electric guitars were sold. Example 3. TV Repair by George charges a $50 flat fee and a $25 per hour of labor for a repair job. Hank's TV shop just charges a flat fee of $125 for any repair job. So, I notice that hours is unknown, as well as the total cost of a repair job. So when I write my system for this one, I'm going to first address TV Repair by George. The cost for George would be a $50 flat fee plus the cost for labor, which is $25 per hour, so that would be $25H. Whereas Hank's TV shop just charges $125, not per hour, regardless of the size of job. So in this one, I'm choosing to graph them because I'm going to be asked to compare which is cheaper for different amounts of hours. So I'm going to do the second one first, C equals 125, so that's going to be just a horizontal line at 125. The second one, I'm going to do this one in red, crosses at 25, crosses at 50 for the y-intercept and has a slope of 25. So it's going to go up 25 over 1. So this is counting by 25s on the y, so up to 75, and I'm going to go right to 1. Just right here. Up to 100 and right to 2. Up to 125, right to 3. Up to 150 and right to 4. So I'm going to draw my line. And the red was the first one, George, by George, and the green one was Hank's. That will help me compare if I label. Alright, now, based on these, I'm going to analyze and answer the question. So, which shop is cheaper if the job takes 2 hours? Well, the cost is on the y-axis. So, that would be the red, which would be George's shop. If it takes 3 hours, they're equal. Both shops will charge exactly the same amount. And 4 hours, the one that's cheaper, well now Hank's is lower. So based on this, it would help you make your decision if you know the amount of time. If somebody could give you an estimate on the amount of time it would take, you would know which shop is cheaper in the long run. So hopefully you see that if your system is in y-intercept or slope-intercept form, substitution's easier. If they're in standard form, I would say that elimination is easier. And if you're asked a lot of analysis questions, sometimes it's easier to graph. Now, if the numbers are really complicated, you might find that you need a graphing calculator to assist in that.